Let's get started and talk about storage now. Storage is a very integral part of whatever you do. Obviously, you want to retain data for long-term access, and maybe it could be a legal requirement to record the transaction your application is making. So storage is everywhere. You are storing a file, you are watching a video, you are sending someone a message before they read, that may be stored somewhere, or even it would be stored in history. So storage is an integral part of whatever we do. I would talk about very basic concept of storage first, and then I'll talk about AWS specific concept. So let's first focus on storage types. Uh, I would divide storage into three different categories. I would call them block storage. Then there are second type file storage, and then object storage. Now, it's not a table where we are saying one is better than the other, but they have specific use cases. Sometimes it would be beneficial to use block storage. Sometimes it would be better to use file or object storage. So we'll try to understand the problem these type of storage solve, and then we will relate it to AWS services, that how AWS allows you to use these storages in an efficient and easy manner. Let me first talk about the block storage. Let's take an example to understand the type of storage it is. Let's consider you got a piece of land, and this boundary is your piece of land. Now you could decide how you want to divide that piece of land and what you want to use in those specific blocks which you have created. Like I may decide, hey, I am going to put garden here, and maybe I would have some open space in my property here. I would have a building, and then I would keep this space for parking. This is my use case. Somebody else may say, okay, we do not need parking. Open space is sufficient for it. Maybe instead of parking, I would be creating a swimming pool, or maybe a shade, or maybe a storage space. So it depends. Idea here is that once you have this piece of land, you are allowed to make your own decisions to decide what you want to keep on it. Maybe I want one portion to be smaller, another one to be bigger, and vice versa. So that gives you the flexibility to create partitions, and in those partitions you are able to utilize different type of storages. You can say, hey, I would be using X type of storage in this partition, I would use Y type of storage into this partition, and I would be using a different type of storage into this partition. So flexibility is there. You take a raw storage, partition it as per your requirement, and then start storing data on top of it. That is a block storage. A very common example of a block storage you could think of is your laptop hard disk. Most of you are using a laptop or a desktop, but there is a disk on that. On the disk, there is an operating system which allows you to boot your machine. Could be Windows, could be Mac, could be Linux, and probably you may also want to have, not very common nowadays, but initially it used to happen that we would divide the disk into logical space. Maybe I would keep my data into a different partition. Maybe I would keep my logs into different partition. So this is possible. Purely you could divide it logically and keep different type of data, or format them with a different file system to keep different type of data inside. That is what we mean by a block storage. It's a very common used storage. We will talk about this, how AWS implements it. Think about second type of storage, file storage, as an apartment block. So this is one apartment blueprint I have here. But obviously it would be possible that there is another apartment adjacent to it, maybe similar exactly in the nature, little bigger, little smaller, it is possible. But apartments are mostly created in a way that one is adjoining to another apartment. And same thing would happen here too. So this side is another apartment. Now, if this apartment is owned by me, I am allowed to make some basic changes here. I could say, hey, I want to change the color of this walls. I want to change the carpet which is there. Maybe I want to have electricity be redone, electric supply to be redone, or electric fitting to be redone. I don't like closet here. Maybe I want it to be shifted to storage, or maybe I want to break this internal thing and make it a big storage. So those type of changes are allowed. But I can't go crazy and say I am going to break this wall and create a door here because that would be interfering with others. So that won't be allowed. Though you are a owner of the apartment, but still you can't create something or can't do something which would affect others. So there are some limitations on what type of operations you can perform here. Giving a computer context. So this is for file storage. In a file storage, the common thing which you would be doing is you would be saving your file. You would create your file, you would share your file, and maybe you want to delete your own file. That is possible. Somebody else may also give you permission to delete their files, but you do not have permission to format the whole storage. This file storage is giving you file level operations which you could perform remotely or from within the operating system of this particular storage, but you do not have the full ownership of the whole file system. You can't partition, format this type of storage. Somebody did it for you and you just utilize that file system. So that is a file storage. Third type of storage is called object storage. Now this is something unique. I would give an example here. I am living into London now. Sorry. Let me give you an example here for object storage. So I am living into London and I moved to London from Dubai. I lived in Dubai for 4 years and in that period of time I have accumulated lot of stuff which I just don't want to leave. I wanted to bring that stuff to London. But as soon as I landed, I could not have a home where I would put all the stuff. So what I had to do, I had to find a way to keep my stuff into Dubai for a while. And once I got settled in London, I could have asked it to be couriered back to me. Now, I could rent a whole house and keep my stuff there. Or I could go ahead to some storage unit providers who provide storage units like this, and I could store my stuff there. Probably they may also have option that they would charge me based on the boxes I keep, or I could go and rent the whole unit from them if my need was like that. This is a easiest example to understand object storage. So this storage allows you to store object. Now, a question may be coming to your mind, what is an object? I would say it is still a file, but there is additional information with that which is called metadata. So it is a file with metadata which you could add to these storages. Sorry, you could add metadata to these files. So that is what we mean by object storage. So advantage of object storage is probably I would be paying only for the number of boxes I keep, or I would be paying only for the duration I use this unit for keeping my stuff. So it is much convenient for me. Once I have settled into London, I hired a courier company. They have taken all the stuff from Dubai, shipped it, and now I have it all back in my home. So this is what a object storage example is. I'll come back to this in a minute. I would explain how it differs from file and what can be done and what cannot be done on that. Now one more word which I use may be confusing some of you is metadata. Metadata refers to data about data. That is the common definition. Think about this box. On this box, I could put a sticker and say you are box number 15. You could put another sticker on top of it and you could say this one has all the kitchen stuff inside it. You could put another stuff on that and you could say this belongs to Ashish. So that is the additional information I have added with the data, which is identifying that data uniquely, or maybe it is identifying the purpose of the data or the content of the data. That's what we mean by a metadata associated with an object. So keep this analogies at back of your mind, and now we would talk about the storage types in technical terms. Block storage, unit of transaction is block. Now we need to understand how this block storage actually works. So let's say this is your laptop or desktop hard disk. I would write HDD for that, hard disk drive. On top of it, you would have an operating system layer. You do not directly go and communicate to hard disk. You talk to an operating system, and then operating system would communicate to hard disk. Let's say you have a program here. Let's say you are using MS Word, and in MS Word you have created a file. Now MS Word may not know directly how to communicate to hard disk. So what it would do, it would send this request to store the file or read the file or update the file to the operating system. Operating system would then communicate to the underlying hard drive and would then store your data in different chunk of blocks. So maybe this file required 10 blocks to be stored. So operating system would decide on hard disk where these blocks would be stored. You and I do not see blocks directly. We see them as a file, but at the backend, unit of transaction here is a block. So your operating system is taking care of creating things at the block level. If I'm talking about file storage will be little similar, but instead of you directly communicating to it, what we would have, we would still have some type of storage. So we would have some storage, probably a hard disk, maybe a magnetic disk, maybe a SSD, whatever, and then you would have some network operating system on that or a software which is allowing us to run network file systems on top of it. And probably file storages would be accessed by different nodes. These nodes would be running some client program, and that client program would allow to communicate to this network file system or network file server. That would be a better name for it. Now, these file clients here would be issuing command to create a file, update a file, modify, or read. That will be taken care by the network file server here. It would go to the storage and deliver you the file you requested or modify the file you requested. So that is a file storage. Okay. Coming to the last type of storage, which we talked about, object. Objects are files with metadata. So I would have a file and now I could add additional informations with it. I could say, hey, file, you are having a owner tab or owner metadata. It belongs to someone. Maybe you would have a price associated with you. So somebody has to pay this much money. Or I could say it has a security clearance level required for it. Or I could say, hey, I have to delete this after some time. So all this information can be added as a metadata. So metadata will help you to identify those objects. Plus, you can use automation for performing some operations on these objects. So you can identify, I need all the file for the tab for the metadata where delete after date is below today's date, and I would go ahead and through automation I would delete everything. So that is the metadata which is allowing us to do. Now sometimes people confuse metadata with operating system attributes. That is a different story. Let me give an example here that what I mean by operating system attributes, and you would probably will understand it much better. Now, if I go to some specific files and check their properties, I would find some information like I am right clicking on one of the file off screen and I will bring its detail here in a minute so you could identify that what that file is. So this is a file and I am just right clicking it and going to its properties. I can see information here like created, modify, accessed. I have information here like details. I could see information here like, hey, where it was done, created, when it was content created, date saved, total ending time. All this information is maintained by my operating system. Now this detail is what we refer as operating system information being stored by my application. Instead of that, if I go to properties of a different type of file, this time I'm going to a exe file, which is an executable files property, and I could see its a detail would be little different than what I have seen for a PPT file. Here the details are little different. It says that this was a file created by Microsoft corporation. So this is the file system attribute. So don't confuse yourself with file system attributes and metadata. File systems may not give you ability to add extra information. So that can be sometimes challenging to some of the people. So let's say I decide, hey, I want to modify something, and in that modification, I want to add extra information. Like here, I have this file AWS CLI.png, and what if I want to add extra attribute here, which will say whom this belongs to, or it would say what the content of it or when it has to be expired. So that may not be allowed by your operating system, but object storages would allow you to create that metadata information. So hope this thing is clear. Let's talk about the second aspect here, which is examples. So if you are accessing a laptop hard disk, as I said, you are accessing a block storage. You can take that hard disk and say, I would partition it on the C drive, like in Windows we call it C drive. I would be creating the or keeping my operating system, and the remaining I would call it D drive, and I would be keeping my data here. So that is my block storage. If I'm talking about file storage, most of the time you would connect to file storage like this fashion. So you will have // server name or IP address slash the folder you want to connect to, and obviously you would need permission to access folder, and you could access it over the network. This is what a file storage would be looking like. If I'm talking about object storages, see the examples here. If you ever used OneDrive or Google Drive or Dropbox, these are all examples of a object storage where you upload something. It is file, could be PowerPoint, could be a video, could be a photo. Those are all being stored as an object here. Now, the next point here is how can you update the object? Now, when I say you, it would depend on who is referred here. Now, block storage, you can directly update the file. So at the end, it is everything is a file. So you would go ahead to your program, open the file and say, hey, I want to delete, modify, whatever, and then you can perform that operation. You would think you are performing the operation, but the request will go to the operating system and it will perform the operation. In file storage, similar thing happens. You can modify that, but object storages are little different. Let me read it out and then I'll explain what I mean by that. You cannot update the object directly. You create a new version of the object and replace the existing one, or keep multiple versions of the same object. What do I mean by that? Let me give an example by going back to our storage option. See this box unit here? Consider I have some thing to be updated or something to remove from this box or add into this box, which is shown here. Probably you can see that, the box. Now, there is not enough space inside this storage unit. So what I have to do? I have to get this box out first. I would perform whatever operations I want on that. Maybe I wanted to add something, so I have added extra information, extra stuff inside, and then I have pushed it back into the storage unit. That's what we mean that object cannot be edited directly. You have to get them out, modify, and push them back into the storage. That's how you would perform modification. Right. So hope this thing is clear. Storage unit are not designed, like if I'm talking about this physical storage units, these are not designed for humans to live. They are designed for stuff to be kept. Maybe some of the storage unit would not have electricity, may not have cooling and heating, because it is not designed for designed to be like a home or a office, but it is designed to as a place to be keeping the stuff. So that we mean by a storage unit. So hopefully this thing is clear. So we talked about storage types, we talked about transaction, we talked about example, and we talked about how you can update. So you would get that object out, modify it, and then you will send it back. Now, when you are sending it back, you could say, I would keep multiple version. This was version 1 and whatever modifications I have done, I want to store that as version 2, so that will also be possible in most of the object storage. So version 1 not having this hash, v2 has that hash, we can keep it, and we can keep multiple objects if the need be, shouldn't be an issue. Next thing we will discuss here is that how you access this or what protocols are used to access these type of storages. Block storages are accessed by protocols SCSI, Fiber Channel, Serial ATA, SATA as we call it. You don't have to remember these. I'm just giving you additional information so that you can clarify things if need be. File storages are accessing network protocol, SMB, CIFS, NFS. You can find full form for it. Server message block is SMB, CIFS is common internet file system, NFS is network file system. So you could clearly see that file system word is being used again and again, giving you an impression it is a file storage. When I'm talking about object storage, object storages would be probably accessible over HTTP, HTTPS using some calls we make. So we may not need a front end for these. These services would allow me to directly open things. Like if I want to store something in Google Drive, I could have a browser open Google Drive interface in that and upload it directly, and I am making a HTTP HTTPS call to get object uploaded or downloaded from it. So that is a object storage. Last point I'll quickly talk about, we already discussed this. So we support metadata information only into object storages. Block storages and file storages would allow you to keep operating system information or attributes of operating system or file system, but not additional metadata which you may want to use for your own purposes. So that was a very generic discussion about block, file, and object storages. We will discuss them each of them one by one. Let me give you a context that how AWS provide you these storage. So AWS has these storages. One of them is, block storage is category. If I talk about, these are called EBS and instance store. We'll discuss about them. Then there is EFS and FSX, Elastic File System, File System X. These are example of file storage services AWS offers, and object storage services are referred as Amazon S3 and Amazon Glacier. S3 stands for Simple Storage Service, and that we would be discussing into the next module. So I hope everyone has a better understanding about differences in block, file, and object storages, and then we will take a short break here, and afterward we will talk about Simple Storage Service, which is Amazon S3. Thank you. See you into the next chapter. Let's talk about Amazon Simple Storage Service, or Amazon S3 for short. Amazon S3 is one of the first few services which AWS has started offering to public. I guess it was live in 2006, so it has come a long way. It doesn't mean it has become old and not getting any new features. Every now and then you would hear this new functionality has been added, and it has evolved a lot over period of time, catering to different customers' needs. There are a lot of things which we could do with Amazon S3. We will focus on some of the concept. As I said, it has been into play for a long time. There are a huge number of feature and development happened with S3. We will focus on some of the core component to get us started, and depending on the use case, we can utilize S3 for different purposes. So let's get started with Amazon Simple Storage Service, or S3. To understand S3, we have to first understand concept of buckets and object. Now, you can clearly relate a concept of folder and files to understand bucket and object. In your laptop or desktop, when you are trying to store some files, probably to make them easy to identify and find, you would store them into folders. Folder is the outer boundary in which you would be keeping files. Let's say a folder for images, another folder for videos, another folder for document, and that's how you would be storing your files. in Amazon S3, the concept of folder is what similar thing is bucket. If I go with the formal definition, buckets are containers for data stored in S3. They keep the data, and inside that bucket, we keep objects, and objects are the fundamental entity stored in Amazon S3. So to get started, you would first need to create a bucket, and once the bucket is ready, you could start hosting objects inside it, and we would be doing the same into AWS console in a minute. Right? So compare bucket is like a folder and object is like a file for a traditional compute workload. Let's get started into console and create a bucket, and we would store some objects inside it. Sorry. So I'm going here, signing into the console, and from there I would create a bucket first and then object. Now, if I come to service here S3, the name itself says that it is a scalable storage in the cloud. Why it is scalable? Because it offers you virtually unlimited storage. You could keep as much data as you want inside, and we would just start by creating a bucket first. Now, when I have to create bucket, I have to specify some basic details, and those basic details will define how my bucket would be storing the data. I'm keeping things simple here. I won't go into all technical detail in this module, but we will talk about other features in the next modules. So let me create a bucket. Now, as soon as I create a bucket, you would see one change happens here, that it becomes global. Before that, if I was just on to AWS Management Console, not going into S3, this was showing me the region where I am connected to. So currently I am connected to Northern Virginia. And as soon as I say, hey, I want to use Amazon S3, if I go this place, it would automatically change to global. What it indicates that S3 namespace is global. So whenever I have to create a bucket, I have to identify it by a name, and that name has to be globally unique. Otherwise, you wouldn't be allowed to create a S3 bucket. Let's try that. So I go ahead here and say I want to create a bucket. I won't explain every option right now, but we will come to them as and when required. So my bucket name, let me try to create a bucket called test, and I do not go through all these settings. I just select I'm fine with the basic setting which is given to me, the default setting, and I say create a bucket. And obviously I get an error because this bucket with the same name already exists. Now whether it exists into Northern Virginia or somewhere, it doesn't matter. Buckets would be a regional entity. So the namespace is global, but whenever a bucket is created, you could select specific regions and then start building your application or data, storing data there shouldn't be a problem. So I will make it unique. Let's say learning AWS, and today's date is 02/02/2023. Sorry, to just make it unique, and I'm selecting region Northern Virginia for it, and I would say done. Go ahead and create a bucket for me. What happens now that AWS would refer this as a bucket, the name which I have given, and it would keep object in this bucket only within Northern Virginia region. It can be accessed from outside if you want to, but physically the data is stored within Northern Virginia region. Unless you specify, those objects won't be copied to another region automatically, because maybe you selected Northern Virginia to fulfill a compliance, so AWS would never be automatically copying your data to a different region. But if you want, you can. Once my bucket is ready, next thing I could do is go ahead and start creating objects inside it. So objects are your fundamental entities stored in Amazon S3. I could go ahead and upload my object. I can create here folder structure if I want to. More on this in a minute. Let me go ahead and upload an object. If you see, there is an option which says upload. It doesn't say create an object. So I would have my object ready, and then I would upload it into Amazon S3. Let's take a very simple notepad file, a text file, and I would store it. So I would call it, this is my object. Done. And let me save it locally. I'm saving this object locally on my desktop calling it object 1, and once saved, I would go ahead and say I want to upload this. I would select upload, and I would be adding the file which we have just created on desktop, which is object1.txt. It will show me the size of file and where it will be going into, permission, properties and everything, and I would upload it. As soon as this upload finishes, obviously it took very short time because it's a smaller file, I would get a message saying yes, everything is fine, upload completed, and that object is being shown to me here. It identified the type of the object. If I click on this object now, I should be able to see a unique identifier for that object. So there is a unique identifier that is referred as object URL. Let me copy it into Notepad so that we can inspect it in a easier fashion. So this one is HTTPS, the protocol, the bucket name, service, Amazon AWS.com /object1.txt. That's how we identify an object. This is a unique identifier for the object. If I'm going to open this object, obviously I should be getting an error, and it makes sense, X is denied. We don't want objects to become public automatically, and that's why S3 default setting is no object is made public unless you specify so. How to make an object public, we will see that in a minute, but let's focus on some additional component associated with Amazon S3. So hope this thing is clear, that what is a bucket and what is an object and how to upload an object to a bucket. You could upload multiple objects also. We will talk about multiple ways of uploading object to. Let's focus on the next component here, which says durability is 99.99999, which we are referring as something called 11 nines of durability, and then availability is referred as 99.9x. I would talk about why I am putting a x here, because there are different storage tiers into S3, and depending on which tier you use, your availability will be different, but durability would remain the same. So let's try to understand what is durability and what is availability. I'll go to a blackboard, and explain these concepts so that you can have a better idea on that. Let's say this is an office building. Let's say I work here. Now, office buildings mostly would have a time to open and time to close, right? So let's say this building opens at 5 a.m. into the morning, and let's say closes at 11 p.m. Right? I forgot my laptop here. So my laptop is there. I realize about that at around 11:30. Can I go into this building right now? Answer is no, because the building is shut. My laptop is not stolen, it is still there, but I can't access it right now. How this relates to durability and availability? Let me write down it first and I'll explain it. Durability and availability. If I could put simple meaning in English here, I would say durability means retention and availability is responsible for access. Let's see this thing here. So my laptop is still there. It is not stolen. It is not, it has not vanished. It is still there. So it is retained for me. That is durability. But can I access it right now at 11:30? Answer for that is no, and that is your availability. What it means in terms of Amazon S3, let's see that. So let's say you created a S3 bucket. In that S3 bucket, you have stored an object, and now you want to access that object, right? This S3 bucket would be in some region, exactly. Now, what happens behind the scene, as soon as you create an object, S3 service would create 3 copies of that object. So for you and me, it is looking like 1 copy or 1 object. Behind the scene, S3 has created 3 copies of object, 3 physically distinct copies, same object. That would ensure that even if one of the copies gone, deleted, or caught fire or something happened, I still have my data accessible, sorry, my data is still stored in a durable fashion. So that is what we mean by durability is 11 nines. If you quantify this durability, some numbers is like if you put some numbers on this 11 9, that comes out to be like if you store, let's say, 10 billion files into Amazon S3 service, maybe over a period of 10,000 years, one file may get lost. So it is very, very rare chance of a file getting vanishing while getting vanished from Amazon S3 as a service. So that is a durability which is called 11 nines, which we could get from S3. And how we could get it? Because the service is keeping 3 copies of our data. So let's say all 3 copies obviously would stay within a region. So there is a copy 1, copy 2, and copy 3. This region is, let's say, Northern Virginia. Let's say for whatever reason the connectivity to Northern Virginia is disrupted. Like I could not go into the building because it has a time and I am beyond that time. So my connectivity is gone. It doesn't mean that my file got deleted. File is there. As soon as my connectivity would be established, my object would be available to me again, and that is what we mean by availability. So availability relates to access of the data, whereas durability relates to retention of the data. So hopefully it is clear to you what is durability and what is availability. So as soon as you store an object, S3 would create multiple copies of it, and they would be stored within the same region, not beyond the region, and you can access those by one single URL which we got as an object name, and behind the scene service would take care of its durability and availability. I hope this thing is clear. Let's go back and talk a little bit more on Amazon S3. So S3 is a service in which you can create bucket, and in bucket you could create object. Every object will get its a unique name. I showed you uploading one object, but let's go ahead and upload bunch of object, and then I'll show you the folder structure of Amazon S3. Now, doing manual object upload one by one from management console may not be best thing. It will take a lot of time. Best would be I utilize some command line to upload huge number of objects. And this is just an example. You may still leverage management console if you want to, and you do not need to remember commands. I am just showing you a easy way to upload some of the object into S3 as a service. So I am into command prompt on my Windows machine. I'll go to a directory which I have is called temp, and there I have a folder which is called static website. If I look here, I have different files inside it. There are some CSS directory, fonts directory, images, index file, index.html. My intention is to copy all these files to the Amazon S3 bucket, which we have just created. So let's go ahead and start that. For that, I am using AWS command line utility. I have already installed this. Obviously, I would need some credentials to connect to AWS service at the backend. So I have AWS CLI installed. It is just an example. You do not have to follow this as it is. I am saying now AWS, I want to invoke S3 as a command, and I want to copy. So the short syntax here is CP, stands for copy. Copy syntax is very simple. You would specify what is the source of your data, and you will say what is your destination of your data. That is the very simple syntax. Copy from source to destination. In this case, my source is the directory where I am right now. So I would represent it with a dot. So I want to copy all the files where I am currently, where to the service which is S3, and then I would provide the name of the bucket we have created. Let's see what was the name. I hope I remember it. Learning AWS 02022023. If everything is fine, what would happen now? S3 my command would execute, and it would start copying all my files to S3 service. I made a mistake here. Uploaded that file to S3. Parameter validation failed, invalid length of parameter. What I need here, I need to provide maybe one more information which will say recursive, because there are a lot of files. I just want to copy all of them with the folder structure. So I'm using a higher option called recursive, and hopefully this time it should work and it should start copying all my files to Amazon S3 bucket of my choice. Let it complete, and then we would see how it is seen into the console. So all my files are copied. I could check it from here also. I could go ahead and say AWS S3 list, ls is the command, and which bucket I am interested to list, I have to specify the details of that. It is a S3 bucket whose name is learning AWS 02022023, and that would display me the list of the object within that bucket. Right. So hopefully this thing is clear. Let me exit from here. Let me go to console and see those objects here. Previously we had only one object, but now I should be able to see the folder structure here. So you could see this is a folder. This is a folder. This is a folder. This is my HTML file, which is of this size. And here is the detail of storage class. We will talk about storage classes in some time. Now, one key distinction here which you should be aware, that how S3 actually stores the data. Let me give an example here. Best would be I write it down on a notepad for easy understanding. So I have here one file which is index.html. So that file is within, that object is within that S3 bucket. So that is index.html is my object. Done. Inside that, or in that bucket, I have a folder called fonts, and inside a fonts folder I have a folder called flat icon, and inside a flat icon I have a file called backup.txt. So let me note down this information. So I have a fonts folder, I have a flat icon folder, and I have a file called backup.txt inside it, an object called backup.txt. And similarly, if I go into some other folders, I would find something else. Let's say I go to images, and in images, I have a file called about.jpg, bg1.jpg. So let me note down this too. So this is my images folder, and then there is a file called about.jpg. Now, what is happening here, that this is giving me an impression that, hey, this is my bucket first, right? So the idea or impression we are getting here that this is my bucket. In that bucket, we have a file which is called index.html. Okay. Then inside it, we have a folder, and in that folder, what I have fonts directory, that is my fonts folder, and inside fonts I have another folder which is called my flat icon, and in that flat icon I have my backup.txt. This is the impression S3 is giving to me. But for S3, all of these are just objects, or we refer to them like, we call them key. So for the first object, the key is index.html. It is a unique identifier of that object. For the second object, the key is this whole name. So for you and me, it feels like a folder structure, but behind the scene, S3 is keeping everything into a flat hierarchy, and that portion is identifying object in a unique key combination. You and me refer them as folder structure, but for S3, it is a key. So this folder structure, which is fonts and images, these are referred as prefixes. So these are prefixes. Prefix name says prefix just before the object they are coming, and they are allowing us to create a folder structure impression. But actually at the back end, everything is being stored into a flat structure. So I hope everyone is clear. Now, if I am trying to access any object, I would obviously be getting an error, and every object would get a unique URL. If you remember this one, HTTPS my bucket name S3 service images folder about.jpg, I could use this button to copy the URL, try to open it into a browser, and I should be hitting a wall because the access is denied. That is the default behavior of S3. Okay, so to summarize what we have discussed so far, we talked about what is a bucket, which is a container for data, object, which is a fundamental entity similar to a folder and a file. There are bucket and object. The namespace of S3 is global, but the buckets we create are regional. We talked about durability, 11 nines, availability 99.9x%. It depends on different storage tier. I'll talk about them. And now you could see this single page summary of Amazon S3. So I would not read everything for you, but this slide is available to you so that you can refer to it and understand more details about how Amazon S3 works, where it stores data, how it works, what are the ways when you can use it, and how much it may cost. We will talk about some of the feature into the next chapter. So I hope you enjoyed and learned something new. We will connect again into the next chapter. Thank you. Let's now focus on bucket policy. Bucket policy is the entity who would define if this bucket can be accessed and if who would be allowed to access this bucket. This bucket policy is written into a JSON format, which is depicted here on the picture. JSON stands for JavaScript Object Notation. Most of the policies in AWS would follow this standard, and don't feel confused here or don't worry. I'll explain you that it may look a little confusing initially, but I'll explain you how this policy is created and how easy it is to create it. But intention is we want to allow people to access the bucket, and that's why we would need a bucket policy to be created. Let me go back to our bucket which we just created. The bucket name is learning AWS 022023, and here if I go and check these object, let's say I go to this file which is called object1.txt, which we created, and I'm trying to access that object, I would obviously will get access denied because that object is not public at all. What I have to do now, I'm keeping it very simple. I want to make the whole bucket public. I'm doing this only for demo purpose. Real life, you will not be utilizing this feature. You would probably use something called CloudFront to host a public bucket, but will not directly expose a bucket. I just want to show you the basic concept, and that's why I'm doing it. Otherwise, in your production account, be very, very, very cautious if you want to make a bucket public or not. Okay, so I can clearly see that access denied. Let me refresh again. It is access denied. Let's now go ahead and allow access to the whole bucket. If I want, I could give access to the object itself, but let's keep it simple. We want to give access to the bucket. Now, before we go there, let me give you an idea that sometime you will see that is called bucket ACL, and there is something called bucket policy. Bucket policy is a new and recommended way. Amazon S3 exists from long time. So in initial days, it was just the bucket ACL and object ACL. ACL stands for access control list. They are still existing to maintain backward compatibility, but recommendation is to use bucket policy. And we will be focusing on creating a bucket policy. As the name says, it would govern the access of the whole bucket. Yes, you can put lot of restriction and lot of settings inside. We will keep it very basic. Our intention is to make this bucket public. We are going to make this bucket a public bucket. Public bucket doesn't mean anyone can upload data. Maybe I want to make it a public bucket, but only for a read operation, nothing else. That is my intention, and let's see how we implement it into AWS console. So I'll go to my bucket, And in the permission tab, I would be able to see block public access setting. I would be able to see bucket policy. This is where I am interested in right now. Now, I could click on this button called edit. And if I want, I could create the policy by writing that JSON here if the need be. That can be a little complicated. Lot of curly braces, comma, semicolons, colons. So maybe we want little help here to create a bucket policy. So one thing is here is policy examples. You could refer these examples, and there is an automated way of generating policy that is called policy generator. For this policy generator, we would need a name of the bucket, which is called bucket ARN. ARN stands for Amazon Resource Name. Every object is identified by a unique name, which is ARN, Amazon Resource Name. Here you could see this is ARN, AWS Service Name, and then bucket name. So this is my bucket ARN. Button is here, so I'll copy this because I would be referencing it once I create policy in my policy generator. So I go to policy generator. By look and feel of it, see the logo, this looks very old way of doing things, but still very relevant. So 3 steps: select the policy type you want to create, add the statement, and generate the policy. It doesn't only create the policy for S3, but you can create policy for SQS, VPC endpoint, IIM, SNS. Right now I am focusing only on S3 bucket policy. So I have to select whether I am going to allow the request or deny the request. My intention to allow the request, fine, so I'll keep it allow. Principle is, if I could rename it, I would say person who would receive the permission. I would say who should be getting access to that. That could be a AWS account. It could be everyone, or it could be a specific user. Right now I am keeping it everyone, and I don't write everyone, but I represent everyone by a star here, which is a asterisk representing everyone. Principal star means everyone. With service is selected is S3 because we selected S3 here, and here are the different actions which you could perform on Amazon S3, and these are independent API call which can be made against S3 service. Create a bucket, create a job, delete a bucket, delete object version. All these calls can be made. Right now I want to just read, and the read here is displayed as get object. So I say I want to allow only reading of the object. The API call I want to allow is get object, so I selected that. Obviously it is a checkbox, so you could select multiple of them. I'm keeping it simple, just read permission, so I just selected one action. Next come where. Where is Amazon resource name would come into picture. So I'll paste the ARN which we copied, which is the bucket name. And if I want, I could add more conditions on it. We will talk about condition in other policies. But I'm keeping it simple, and now I say done. Let me add the statement, and this will be added. That will generate the policy. So I'm on the third state. This is done, and I say generate policy. What I get here is the JSON which is generated for me. If I read this JSON, let's see what is telling me. ID, a unique identifier for the policy itself. Version, don't get confused, this is not a version of the policy, it is the version of the JSON who would interpret it. So this is a JSON version of 2012.10.17. This is the important thing here, statement. Statement can be multiple into a policy. So this is first statement or a unique identifier for the statement within the policy. And here I say action. What I want to do get object. Am I going to allow or deny it? Effect would decide that. Here it is allow. And which resource? So this is the name of the resource I have. And then to whom, principal is star. This is my policy. So I'll copy this policy. Done. And I would go back here to my S3 console and I would right click and say paste, and my policy is getting created here as you see. So I don't have to manually create policy. I could take help of policy editors and I can create a policy like this. Now, once I click on save changes, I would get an error and I'll explain you what that error is. So let me go ahead and show you that first. Save changes. As soon as I save change, it says unknown error. API response action does not apply to any resource or resources in statement. Let's read that policy again. So this policy is applied on a bucket, right? And we are allowing an action which is called get object. So we are not defining which object, we are just defining the bucket. But what it needs the name of the object. So here I could have said I want to allow this action only on object 1.txt. So only that object would be applied with this action and this particular effect. Or I could say I want to make every image available. So I could say there is a folder called images and I have my JPG files inside and I want to make all of them public. So that is one option. Or you could say, hey, I want to make the whole bucket public, means all the object. So I would just represent it with a wildcard here, which is /star. So once this is ready, hopefully I should not be getting an error, and now I say save changes. Then I got one more error. Right? Error is a good way to learn things, and let me explain what this error is. This says your bucket policy change cannot be saved. Okay, let's see what happened. You either do not have permission to edit the bucket policy or bucket policy grant a level of public access that conflict with your block public access settings. This is the key thing here. If you look on the left side, you would find here a setting which says block public access setting for this account. This is a very nice feature. Let me say why this feature may be required. Let's consider that you have a account. This is my AWS account. And within that account, I have multiple buckets. I won't use the bucket symbol, but let's represent a square with a bucket. So these are my buckets. In those buckets, obviously, there would be objects. So there are objects here, and maybe there is a folder structure. And within that folder structure, there are objects. So that is all possible. Now, somebody somewhere down the chain has created an object and made that object public, which is violating my policy as a company or as an individual. I don't want that. And there may be hundreds of buckets, thousands of objects, and that would become nightmare to go and select what could have went wrong. What if we could give you a setting on the bucket level itself who would control the behavior of the whole bucket regarding public access, and not only for the existing object, but that policy will dictate that any future object which are created won't violate the bucket level setting which here. They won't be violating the bucket level setting we have defined. So that we will discuss. What if there are multiple buckets, do I have to configure the setting on every bucket? So why don't we give you a setting on account level which says block public access. And again, block public access for current object and for any future objects too. Both options are there, you could select it. So this will make my life much easier as an admin or as a user, because I could go to one place, select one checkbox, and everything is protected. Not even existing or future object would have a potential to become public. That's the setting defines. And by default, that setting is selected. That is a default behavior, that every bucket you create, by default it would say block public access. So even if somebody puts a policy like I was trying to, I would get an error. So first I will fix that issue and then I would make that bucket public. So hope this thing is clear. Let me go to the console and try to see that problem. So I will keep this thing here because I will come back and click on save changes. Let me open this setting into a new tab. So I'm coming here on S3 management console and I would see block public access setting for this account. See this is off, right? I could edit it and I could say I want to enable this, or I could go ahead and say this thing on the bucket label itself what I want to allow or not. So I go to this setting bucket and here is my bucket. I'll go to the permission section and if you see this one is on here, that is a default. So I could go ahead and say okay, no, I am okay to remove block public access, fine. Let's read the statement. Block all public access, one checkbox, or if you want to be selective, which says block public access to bucket and object granted through new access control list. Means what if somebody later adds a section or setting which will allow access, so I want to block that too. Second says block public access to bucket and object granted through any access control list. That would mean existing access control list also. So either existing access control list or new access control list to block the access, or if somebody goes and says I would allow the access through bucket block policy, sorry, public access through bucket and object public access point policies or other access point or new public access point policies, I could block them too. So this setting is basically like a top level checkbox which would ensure not existing nor neither existing nor the newer object would have a potential to become public. What if the wording could be potential become public? That would be much easier, but we have to live with what is available here. So this is called block all public access. I have unchecked it. Default setting was checked. Let me again show it in case you forgot about it. So I'll come back here. I will check and by default setting says on, which is blocking all public access. And that is where I was getting the error. I would remove that. Once I'm happy, I would say save changes. It would ask me for confirmation. We don't want it to be just by manually clicking something and not knowing what we are doing. So we are confirming here that I am okay with that. We would still highlight this thing to you that this object can be public. It's not saying object are public. It says object now have potential to become public. And once I have made that change, I can come back to my policy where I was getting error and let me invoke the save changes again and let's see what happens now. I say click save changes and this time everything is successful. I got a green signal here which says successfully edited bucket policy, but on the same time we also give you a red signal, hey, you have made your bucket publicly accessible. So just highlighting it so that you would know as soon as you log into console, even if you have hundreds of bucket, this symbol will tell you that this bucket is public. And if this worked fine, my file which I was not able to access object1.txt, let me refresh it and I have now object visible to me. This is my object which we have just created. So what we did here, we made that bucket public, which mean every object within the bucket got public access. If I wanted, I could have restricted it to specific object based on prefixes, suffixes, it is up to me, or I could put more restriction. We will discuss them into the next section. Now, while we are here, we can also leverage one feature of Amazon S3, which is called hosting a static website. So website is where we would be keeping some of the HTML files, CSS files, and through which my users would be able to access my application or the content. We refer that as a static website. Let me show that setting and I'll explain what happens when we enable that feature. So we have this bucket learning AWS, and then once I go inside, there is an option which says properties, and in the properties I would go down and there would be a setting which says static web hosting. What is a static website? Let's quickly talk about that. Now, if you are accessing a website, a common way to host a website is on a server. So you would take a server that will have its operating system, there would be some web server software installed, and then you will host your website on top of it. And obviously this one has here hardware available, so it would do processing, so it has CPU and RAM available for performing processing, and your website may contain a PHP code, or it may have some Java application to run, and once my users from here access it over a browser, that website would be displayed to them. This is a traditional way of doing the things. But if you remember, our S3 objects are also getting a HTTP endpoint. So why don't I use that HTTP endpoint and host my website here? This website which I'm talking about, which has PHP and Java, these are referred as dynamic website, because they would be doing some processing behind the scene. They would use the memory and CPU of the server and perform some operation, maybe make a call to database, maybe do some calculation, maybe display something, and then after the processing is done here, the result are displayed back to my user. That we mean by a dynamic website, whose content will be dynamically created. On the other hand, static websites are the way where content is not changing. In this case, what we will do, we will host a static website into an S3 bucket. A website may contain HTML file, CSS file, maybe PHP file, Java file. In this S3 bucket, I would be keeping standard HTML files, maybe your image files, maybe some font, maybe some CSS file which will display the cascaded sheet in style sheets onto my website. But S3 doesn't have any CPU power. It is a storage service. So it cannot run your PHP or Java, but what it can do, when a request comes to S3, it can deliver those content back to the user, and now user has a browser. This browser can also run some script. So S3 would deliver those script when the request comes in, response is given, and those CSS file or JavaScript are executed on my user's computer. This browser is running on their computer, and this time it would use processing power of computer here. So this is doing processing on the client side, and the website I hosted like this is referred as a static website. All right. So maybe a longer discussion for some of you who already knew it, but let me go ahead and enable a static website feature. Very simple feature. I would just need it to point it to a HTML file, and then I would have access to a website directly coming from S3. If you remember, in my previous session, I have put lot of object inside this particular bucket, and this constitutes a standard website which is made up of CSS, images and all, and this is the important file for me, which is index.html. If I go to this, I can copy this object's URL. This would change when I enable a static website feature of it. So let me keep it here for my object. This is my object URL which we have. I would now go and enable the static web hosting feature, which is currently disabled. Very simple. Edit. I would say I want to enable it. And read this information. It says use this bucket to host a website or redirect request. So both can happen. Somebody can be coming here and they can be redirected to other website if the need be. Right now I am interested into hosting a static website. Use this bucket endpoint as the web address. Yes. Who would be my landing page? Who would be my default page when somebody visits this website? So I could give it a name index.html. It's not mandatory to use the same name. You could call it anything, but index.html is the most commonly referred as a default page. If you want to put a error document, you could do that too. You could redirect based on the JSON setting you define. I'm just keeping it as simple as possible. And now I say I want to save changes. What happens now? I would be getting a different URL to refer the whole website. Let me see that URL here. So this is my bucket website endpoint. This I would take put it in Notepad so we could compare. I'll come here, and here you could see this is coming from the same bucket, but this is referred as S3-website-US East-1. This is representing me that, hey, this is a website hosted on Amazon S3. It is not referencing to a specific file, but is representing the whole website here. Let me copy this information, and I would now open that website into a browser. Now, before I open it, you may be wondering, hey, this doesn't look like a very cool name for my website. I agree on that. What you would be doing, we will be talking about that this is a URL which S3 has given. You would be then using services like Route 53, which is a DNS service where you would say this would be my coffee website.com should be redirected to this particular S3 location. So user would type mycoffeewebsite.com, and behind the scene this would be responding to it, so it would keep the name easily memorable rather than remembering this thing. Okay, so I'll go back here and I will say, all right, let me open this website. This website is just a standard website coming directly from S3. This may looking like images are coming up. It is dynamically displaying things. So there is a menu, there is a blog post available. I could go to shop, but everything here is running from a standard S3 bucket. So really nice feature. If you do not want your website to do a lot of processing behind the scene, you just want to have a web presence, you could go ahead and build this type of static website. Shouldn't be a problem. All right. So I hope everyone has enjoyed. Now, to get this to work, you would need to have the website setting configured, right? So I'll go back to that setting to show you again. You would need the website setting configured in the properties tab, which is here, static web hosting, and you would also need public access setting. Unless the bucket is public, that setting won't take any effect. So if you do not have this bucket marked as a public, it won't work for you. So I need to have both the settings in alignment for my coffee website to work. Okay, so I hope you learned something and you know now a little bit better about how Amazon S3 works, what the endpoints are, and I'll talk to you about new features or other features of S3 into the next topic. Thank you. Let's talk about pricing of Amazon S3. I'll talk about very basic principle of pricing in AWS, and then we will relate those concepts to Amazon S3. If you talk about any services in AWS, common principles remain same. So four basic pricing dimensions. What are these four basic dimensions for almost every service? One is the processing. When the service is using some compute resources to process your data or to accept your request or to perform some operation, that would be constituting or that would be attracting some charges. If you are storing something, obviously that would be a storage capacity utilized in AWS environment. You would be charged for that. Network charges, which is data transfer. Most of the time, data transfer in or sending data to AWS is free, but once you start downloading that data or accessing that data in a outside boundary, you would utilize data, you would be attracting data transfer charges. So these are three very common dimensions for almost every service: processing power, storage capacity used, and data transfer or network traffic. Almost every service may have one more dimension, which is your specific to service. So that would depend on which service it is. Like for S3, it could be something else. For EC2, that service specific thing, something else. But these three common things, processing, storage, and network, they remain the same. Now, AWS has done a good job in keeping all the pricing information available. You could access pricing of a AWS service by going to this URL, https aws.amazon.com. Replace this service with the name of the service and you will get to the pricing page if you put slash pricing at the end. So if you're looking for pricing for Amazon EC2, you would put EC2 here. If you're looking for pricing for S3, you would put S3 here, and it will take you to the pricing page of that specific service. Let's quickly go to one of the pricing page and we will see how that pricing page looks like. So I am here on Amazon S3 pricing. This will be multiple dimensions associated with that. So see this is storage price. I'll talk about that. Request and data retrieval, data transfer, management and analytics, replication, and S3 object lambda. These are the different dimension into S3. Now how I relate it to the compute network and storage. So see, this storage is obviously what you store. Request and data retrieval. This is where you would be charged based on number of requests you send, like put or get request or a lifecycle transition happening on an object, or you are retrieving data. So that time there would be charges associated. That is your network or data transfer. Sorry, that is your request pricing. That is your compute pricing. And then obviously network data transfer. So if somebody is downloading the object you have uploaded into S3 bucket, then you would attract the charges, and that is what will be there. So data transfer into Amazon S3 from internet is free. There are no charges on that. But once you start downloading data out of Amazon S3, you would attract some charges, and this one is for sole region. Similarly, it would depend on different region that what could be the pricing associated with those specific services. So these are the dimension for Amazon S3. So the dimension for S3 in terms of compute, we focus on number of requests you have sent. In terms of storage, obviously the capacity you consume into S3 for storing your object, then data transfer charges when somebody is downloading those objects, and other charges could be monitoring, management, analytics related. So these are the basic dimensions for Amazon S3 as a pricing. There is a tool available by which you could estimate the pricing, which is called AWS pricing calculator. So let me quickly go to it and perform some very basic operation on how to calculate cost related to Amazon S3. I have to start with the location. I select a specific region. Let's say Ohio is fine for me as of now. I would go ahead and say I am looking for pricing of Amazon simple storage service. I would go ahead, configure it, and provide some information like what kind of cost I am looking for. So S3 has storage classes and other features. We'll talk about them in a minute. Let me first focus on something called S3 standard. In S3 standard, I would have storage cost. So let's say I store 10,000 GB data per month. How will data be moved into S3 standard? Is your data already available? So there will be no charges for transfer in this case. Then I have to specify number of requests coming to S3. Put, copy, post, list. Put is when somebody is uploading an object, that is called a put request. Copy, simple, you know. Post, again a similar type of request, and then list, where I would be listing the content of that S3 bucket. That would be called as a list request. So I could put some rough numbers here that hey, I would be accessing this much of put request, and maybe I would have more than get select other type of request coming to S3. You may provide the data returned by S3, how much data you may be returning. Let's say I would be transferring around 5,000 GB per month, and data scanned would be, let's say, 10,000 GB per month. So that information I could put here, and I can go ahead and check the calculation associated. So there are pricing associated. I would be paying prices for of $254. Out of that, S3 standard storage cost is $230. For the number of requests coming in, I am paying some amount. Then for select, again some amount. For select scan, again some amount, and the total cost is sum of storage cost, data request, and S3 select cost, which is coming up to me. And here is my data transfer calculation. So I could go ahead and put some information like, hey, how much is my data transfer? All other regions free, internet free, outbound I'm transferring, let's say, to service called CloudFront or maybe to internet. I would provide the detail of that, maybe 10 terabyte per month, and that would cost me some amount which is shown here, how much would be the cost associated with that. So that is an easy way to get detail of a service pricing, you can save and add this service, and then maybe your architecture requires other services too. So you could keep on adding those services, and afterward you would be seeing the summary of what is the total estimate cost coming to be for your environment. So I hope this thing is clear. That is very basic information about how the pricing actually works. So we are focusing here on storage class of S3. We'll discuss what the storage class is. Let me first go to the formal definitions of it, and then I'll give you my version of it. So Amazon S3 offers a range of storage classes for the object that you store. You choose a class depending on your use case, scenarios, and performance access requirement, what you want to achieve from it. When you think about class, very commonly people relate it to business class or economy class. So that is same thing here also. Obviously not exactly the same, but similar. As I would say, if you're talking about business class here, maybe you would be getting more catered service, right? You would have more legroom to seat. Maybe you will get extra luggage to carry. Maybe you will be getting deboarded first. You would be onboarded first. That kind of privileges you have when you are into storage class like first class, business class. Then there is economy. Economy would be still taking you the same time to reach to the destination, but it may not be that comfortable as your first class or business class could be. Now, decision to travel in business class or first class, I would say it depends. Multiple factors, cost, maybe the distance of the flight. If it's a long distance flight, probably you would prefer business class or first class so that you can relax a bit. If you are having a presentation next morning, it's a long flight, probably you would prefer to go business class. Otherwise, if you just want to have a short distance flight and you are traveling just for uh, maybe you want to save some money while you travel, why not go economy class? Nothing wrong about it. So it depends, purely depends on use case. Here the use case could be comfort. In other cases in S3, the use case can be different. So we'll talk about it. So keep class will give you some functionality, and then I'll give you a very basic example to relate different classes of Amazon S3. Now what you see here, these are representing different classes of Amazon S3 which is available. So one here, which one is a icon representing something called standard class. Here this one is representing something called S3 class called Glacier, and here this one will be representing your infrequent access class. So I'll talk about these classes through an example so that you can relate these concepts in real life. If you have come to London, you would know that London is divided into different transport zones. Transport zones are like this area, which is maybe you are seeing the color here. This one here is your transport zone number 1. If you see this thing here, it is 1. Then coming out 2, 3, 4, and then 5, 6. That is how the transport zones are divided. Central London, where all these attractions are, like your Big Ben or maybe Buckingham Palace, or maybe you are going to London Eye, these are all into Zone 1. How this is relates to AWS storage classes, S3 storage classes, let me give you an example. If I give a better map of how the storage classes looks like, sorry, your transport zone looks like, this is how the transport zone looks like. This is a central London, and then we keep on moving forward 1, 2, 3, 4, 5, 6, depends on where you are staying. Obviously, where you stay will have a different time to reach to London. If I'm staying in zone 1, I would be easily reaching to nearby area. If I'm living into Wembley, I would have to travel a little bit. And if I'm going further, let's say I'm staying into Epping or I'm staying into Mayfair, I would be traveling much further to come into London. All right. Now, let's say you are a traveler and you are coming to London for, let's say, 10 days. And obviously, being a traveler or a visitor or let's say a tourist, you have a 10-day itinerary. And in that 10 days, you would be going to different places. Probably you would be going to central London, maybe to some cities outside of central locations, and maybe visiting other places. So maybe your itinerary is like 4 days. You would be visiting out of 10, you would be visiting central London, and remaining 6 days, you would be visiting other cities. Maybe you would be going to Reading, Oxford, Cambridge, wherever you want to. So outside of the London. Now, If you're just coming as a tourist, probably you have to book a hotel. Now you have an option to book hotel. I could say I would be booking my hotel into central London. Obviously, cost of central London hotel would be higher. But the benefit here would be that if you are traveling within that central London, then you would save on your transport cost because the charges would be much lesser for taxi or public transport would be much cheaper because you are staying in central London and for the first 4 days you are visiting central London places. So that would be a much better choice. Afterward, if you realize that I don't have to come to central London anymore, I have seen everything whatever was worth seeing, and now I want to go to other cities into England or into Scotland, that time it would be a better way if you could to maybe get a hotel somewhere like little bit of outside. If I'm staying in a hotel which is outside, I would be paying less money in this case. But if you stay outside, let's say you started staying into zone 5 and now for whatever reason you have to keep on coming to central London again and again, then you would end up paying a lot of money into your transport cost. So you have to find a balance whether you what is your use case. Do you have to visit central London again and again, or do you need to visit outside cities of London? So decide on that. So this is one idea where based on my requirement I am either paying more cost for storage or I am paying more cost for access, right? So depends on what your use cases is. The storage class we are going to discuss are designed with need in mind of what is your need. Do you want to store for long period or do you want to access it again and again? So what is your frequency of access? Based on that, you would be deciding on which storage class will work best for you. Right. So same example here. In central London, if you're laying in city center, you would be paying more money for hotel, less money for taxi. But if you are staying little away, it will take more time for you to reach to city center, but you would be paying less money into hotel. So it depends. Similarly, S3 has provided you storage classes. Let's see the options associated with that. These are the different storage classes which are right now available with Amazon S3. S3 standard, intelligent tiering, standard infrequent access, one zone infrequent access, glacier flexible retrieval, glacier deep archive, and glacier instant retrieval. These are different type of storage which are available to me. These storages can be chosen or these classes can be chosen based on your requirement of access. So if your access frequency is very frequent, you would be needing that data again and again, probably you should look for S3 standard. But if you feel that, hey, I won't be needing this data again and again, probably you should be looking for a glacier type of storage. Or if you want to divide it, one more classification sometimes people make is about hot data, very frequently accessed, warm data, sometime accessed, and then cold data, which may be accessed rarely kind of. So depending on these use cases, you may select different storage classes. Now, one more clarification here. The storage classes can be set on a object level if you want. So you can have one single bucket, and in that bucket, you can have, let's say, 1, 2, and 3 objects. First object, I may say I would keep into standard access. Second object, I may say I would keep it to one zone IA. Third object, maybe I would be keeping it into Glacier, no problem at all. They can still be part of the same bucket, but their classes can be different. If you do not specify anything, by default, the standard class is chosen for your object. Like we have uploaded some object for our website, that is by default going into standard. Now, what are the use cases for different type of storage classes? Let me go and talk about these things. I won't read everything, but I'll give you an idea that when to use which one. So first one here is a S3 standard class. This is good or designed for frequently accessed data, a data which you would be accessing more than once a month and you would be getting millisecond access. Your data would be instantly available in millisecond. Intelligent tiering requires its own discussion, so I'll talk about that into next slide. Then let me talk about something called standard infrequent access. infrequently access data once a month with millisecond access. I still get my data into millisecond, but my frequency is less in this particular case. Right. Now, let me give an example that when this kind of architecture could be better. Let's say you have an open position in your company, and for that your HR has initiated requests to get CVs. A lot of people have sent their CV. And HR has amended that this position has to be filled up into 30 days. Okay. When the CVs have arrived, that time HR would be working frantically, scheduling interview, calling people, scanning through the profile. So that 30 days, let's say we have 100 CVs, those CVs would be used again and again, accessed again and again. That is a good use case for a standard class because I am accessing that data frequently. Let's assume everything goes well, candidate accepts the offer, shortlisted, done, and now these resumes or CVs are not of that much use to me. What I would still want to do, I still may want to keep it. So if in future we have any requirement, we could go to this, look, this is CVs and then again recycle them to select the right candidate for ourselves. But my frequency may not be as much as I was doing for 30 days. So I may want after 30 days, I still want to retain the data, but my frequency won't be that much now. What I can do in that case, I could keep that data into standard infrequent access. Here I would be paying more money. If I'm going to standard infrequent access, I would be paying less money in that case. Now, I would say one tool is very best to see this kind of costing, but I'm not sure till the training is released that tool will be still available or not. But right now, let me show you this information here, which is AWS S3 simple monthly calculator. This tool is going to be deprecated. I still like this because it's very easy to get started. Let me go ahead and quickly talk about the storage class pricing here. I can just put some numbers and then you should be able to see some data. You could do the same calculation into your S3 simple storage service tool also, this calculator, or you could get information from this page, but this one is little easier to get started with. So I'm going into Amazon S3. I'm selecting Amazon S3's North Virginia region to be getting started with. And here is my S3 standard storage request. Let's do one calculation. I say I would be needing 10,000 GB data to be stored, and on top of it, I would be having 100,000 requests for put copy paste, right? That is my request. I am skipping intelligent tiering now. I will come back to it. And then I say I would be storing the same 10,000 GB data into standard infrequent access with the same number of requests, right? And I am picking up other things, other classes here, one zone IA, Glacier, and maybe here is a Glacier select, Glacier deep archive. Let's select Glacier deep archive to store the same 10,000 GB data. And I am trying to retrieve number of requests here is this much, right? So these three categories, I am comparing two entities. One is the capacity and second is the number of requests for three categories of storage. Glacier deep archive, I have put numbers for standard infrequent access S3 standard IA, and I have put the number details for S3 standard storage request. Let's now estimate our monthly bill. So this is automatically populating the numbers coming up here. Let's go ahead and see this. Right. So S3 service standard storage will cost me $230 and my request will cost me 0.50. But in case of infrequent access, my cost of storage is almost half or like 40% less than 230. But if you see, my cost of retrieval has gone up. So if I store data into S3 infrequent access, good thing, I would save money. But if the same data I keep on accessing again and again, then I would end up paying lot of retrieval cost for it. Like you have to come to central London every day and you have picked up a hotel very far. You would still save money in the hotel rent, but you would end up paying a lot of money for traveling from hotel to central London. So it depends on what your use case is. You would select what works best for you. And Glacier Deep Archive, see the cost difference? It is just charging you $9.90, not even full $10 to store 10,000 GB of data, which is huge. So why not use Glacier for everything? See this cost here. Put copy request cost is just like 10 times of what we have paid here. So that would depend. Plus, Glacier Deep Archive may not give you access of data into an instant millisecond latency. That is the second thing here. So if I'm having Glacier Deep Archive, long-lived data, access less than once a year with retrieval of hours. So that will be some time you send a request to Glacier and then it will figure out a way to deliver data to you. We'll talk about Glacier in a minute. But hopefully this thing is clear that these are different storage classes and you can decide depending on use case of your data and retrieval request where would be the best type of storage class to use and where to keep your data. So decide on what works well for you. Here, one more important one is called one zone IA. If you remember, I told you that in S3, as soon as you upload or store an object, it gets three copies created. It has three copies created for itself. That automatically happens. But that copy maybe, probably, is going, let's say, into one availability zone, into second availability zone, into third availability zone. So that is giving us a better way to retrieve data. Even if AZA, AZB or AZC is down, we can still get data because at least one of my AZ would have the data available. But if I'm going to one zone IA here, that says recreatable infrequently accessed data stored into a single availability zone still can be accessed on millisecond. What is going to happen here? Like here we were using AZ, A, B and C. Probably in this case of one zone IA, we would be having our data only stored into one of the availability zone. It would still be maintaining the three copies. It's not like one copy is maintained. Still there are three copies of that data. That's why we say S3 is designed for 11.9 of durability because it is still keeping three copies of your data. But in this case, your availability would be lesser. Why? Because in previous case, if your data was stored in three locations, even if one of them is down, then you can still access the data. So you could access the data much long term. Sorry, you can access the data in a highly available fashion. But in case of AZA only storage, if AZA is disconnected, you may have some downtime and you may not be able to access the data. So it depends. If I have some data which I can recreate, like I have images and I have generated thumbnails of it, I may store my images, let's say, into this tier. But thumbnails I keep only into one zone IA. In case this is not accessible, I still have my source data, and from those source images, I could again recreate thumbnail of images if the need be. So any type of data which you can recreate probably would be best suited for one zone IA. We still get access into milliseconds, but it may not have the same levels of availability which a standard storage may give you, right? So hopefully this thing is clear. Now next is Glacier instant retrieval. So we'll talk about Glacier separately, and the next one here is called reduce redundancy, which is for non-critical frequently accessed data with millisecond, but we say now not recommended as S3 standard is more cost effective. So this is kind of a phased out storage that is still exists, but better not to use it. Cost wise, there is no benefit. So by default is standard, and depending on your use case, you may utilize any other storage classes if there is a need for it. So I hope this thing is clear. We have to talk a little bit more on to intelligent tiering, and then we will go to the next module. Let me talk about intelligent tiering. Now, let me give an example that why we need intelligent tiering kind of option. Let's say I have a bucket, and in that I have configured rules. Rule says that as soon as the data is created, keep the data into S3 standard for 30 days and we can automate this process. And as soon as 30 days finishes, transfer this data after 30 days to maybe your standard infrequent access. Your HR worked on the resume, no longer needed, still have to be stored. So we put it into standard infrequent access, and maybe after 90 days of retrieval of storage, I may want to move it to Glacier and keep it there, and that will be kept, let's say, for 365 days. Just giving an example. So it depends on how you want to move the data. But this rule, when it is created, this rule is triggered based on the creation date of the object. When the object was created, based on this creation date, it would be moving forward or into different tier. Now this is good, but let's see an example. Let's say we have uploaded a video here into S3 standard. It was there for 30 days, nobody used it, and then it moved to standard infrequent access. So it is no longer here, which means now this video is staying into standard infrequent access, and let's say somehow this video now becomes viral. A lot of people are interested to access this video. That would mean that this will be charging me more. There will be more charges to pay because this will charge me extra when I am retrieving it very frequently. So this can be a problem for data for which we have unknown access pattern. Like people upload hundreds of videos, thousands of video every day. I don't expect all of them to be viral every time. So maybe some object may go viral, some may not. But our rule here is just based on the creation date, and it may not be best suitable for unknown access pattern data. So what we can do in that case, we want a rule which would trigger based on the access date of the object. That is what we mean by intelligent tiering. So what intelligent tiering would do, it would help me in identifying the access date, means automatically system would do it for me. And based on access date, if data is being accessed frequently, it would be kept into your hot tiers. If it is not being used, then it will go into warm tier. If again for longer length of time not used, it would then go into your cold tier. So based on access date, my data would be moved from one tier to another tier. That is what we mean by S3 intelligent tiering. Let me show this here into slide. So it optimizes cost by moving object between four access tier when access pattern changes. So my object would be monitored, the access pattern would be monitored when that object was accessed, how many time it was accessed, and based on that, my data would be moved to frequent access tier. If it is there, object uploaded will come here, automatically stored in infrequent access tier. If that object is not accessed in 30 days, it would go into infrequent access tier, object not accessed for 30 consecutive days. And if my data is not accessed for even 90 days, it can go to archive access tier, and even after 180 days nobody has used it, it would go into deep archive access tier. This is purely based on access date, not based on creation date. So what would happen now? I could go ahead and say now if my data access happens, what would happen if my data was in infrequent or archived tier? Now, anytime an object is accessed, S3 intelligent tiering moves the object back to the frequent access tier. So come what may, wherever your object was, if it suddenly becomes something which people are looking for, then it would be placed into your frequent access tier, whether it was residing in infrequent or archive or deep archive, it doesn't matter. It would automatically move to your frequent access tier. That would make your life much easier, and it will intelligently do cost optimization for you. You don't have to manually create any configuration. Just keep that data into S3 intelligent tier, and it would automatically monitor it and will move it to different tier depending on how much is the access access happened or not did not happen. Based on that, this data would be moved into different tier. So this is a nice type of mechanism for unknown access pattern data. If you know your access pattern, then probably you should create rules for it, and those rules are called S3 lifecycle policy. So I'll talk about lifecycle policies in a minute, but best would be we go to console and see how this service actually looks like into console. So I'm going into AWS console, signing in, and I'll try to upload an object, and that time I can decide which storage class it would belong to, or afterward also I could transition it from one storage class to another class. Shouldn't be a problem at all. So I'm going to the bucket which I had here. In this, I would try to upload a object. It could be any object, doesn't matter. I would go ahead and say I want to add some files. Let's say same object, object1.txt. Here, last time I didn't spend any info or didn't change anything, and that's why it by default went into standard. See this. So here is a more detailed information. Standard frequently accessed with millisecond. It is stored into 3 availability zones or higher than that. One zone only in one, and that all information is there. So if I want to move this object to any of the other tier, I could just select, hey, you would go into standard infrequent access, and then I would say upload, and now my object is being uploaded into S3 standard infrequent access. I should be able to get that information here. If I'm looking at this, see this, all these objects are in standard, but only object1.txt is into standard infrequent access. So within same bucket, you may have different type of tier based storage. Shouldn't be a problem at all. So you decide what works well for you based on the configuration. You based on your application requirement, you could move your object from one tier to another tier. And here if you see, here is again my option. I could further, I feel now this object has to be changed to somewhere else. I could edit its storage class and again select where it would be moved. Let's say I want to move it back to standard, and then I could save changes and it would be now stored into standard class, right? So this is very easy, and we will see a way to automate it into the next section. So we'll discuss what is lifecycle policy. So stay tuned. I'll talk to you into the next section. Let's talk about another service called Amazon S3 Glacier, or it is just referred as S3 Glacier. Now, if you know about glaciers, this is how it looks like. And if I read the dictionary definition here, it says a slowly moving mass of ice. So one thing it is clear that glacier has something to do with Amazon S3 Glacier. Amazon S3 Glacier is also designed to keep your cold data. It's a storage service optimized for infrequently used data or cold data, and it is suitable for data archiving and backup. So in case you want to retain your data for a very long period and then pay less prices on it, then probably the Glacier would be the best service to utilize. Right. Now you can use this service independently, or you could use this with the lifecycle policies of Amazon S3. So you could say, I would just store data into Glacier without using Amazon S3, or you could say, I would transition my data to Amazon S3 Glacier by lifecycle policies of Amazon S3 service. So it depends on how you want to entertain the data which will go inside Glacier. Now, in Glacier, the concept is of something called a vault. A vault is a container for storing archive. Archive could be any object, which is a document or a video or a photo that you would be storing into a vault. Base unit of your storage is archive. And if I compare it with S3, you could relate like in S3, we call that container a bucket. Here it is called vault. In S3, we refer those files and components as objects. Here it is referred as archive. And in S3, object size can be maximum up to 5 terabyte, but Glacier allows you to have maximum 40 TB as an object size. Now, when you want to get started with Glacier independently, not with S3 lifecycle policy, then you can go ahead and search for the service called S3 Glacier. And inside that Glacier service, you would be creating something called Vault. So you could go ahead and say, hey, I want to create a vault, give it some name, let's say call it keep for long. I could get some notification coming from it and create a vault. Done. Now, if you see here, I do not have lot of properties associated with the vault, or I do not see lot of options here. So I create a vault which is possible from command line as well as console like I did, but the rest of the operation which are related to archive like uploading something, downloading, deleting, you would require CLI access or you would be writing code through API you would interact with it. It's not directly giving you an interface where I can upload an object into Glacier. You would need to use CLI or there would be a code which you have to use or write on your own. And I am giving you a reference here for Amazon S3 Glacier with CLI. So in this, you should be able to see some of the commands which can be used to initiate up archivals and store data inside Glacier service. So help is there. This is a command line where you could go and get help from it. And then you could use some command which is for creating vault. You can copy paste it, replace it with your account ID with the vault name you want to keep it. And once it is ready, you would prepare some file for uploading. This is a demo file. They are creating a local file on a machine and then uploading it. You could do the same in Windows too. And afterwards, you would issue a command to upload this file into Glacier. So hopefully this thing is clear and you got a better idea on what is Amazon S3 Glacier. Now, within Glacier, we again have tier-based option, or you can call it Glacier classes. So there are three storage classes which has different optimization for access pattern and storage duration. First one here is your Glacier Instant Retrieval. As the name says, it can be used for data which I want to keep, but I need to instantly retrieve in millisecond retrieval time. This one would be well suited. This is relatively a new offering from Glacier service. Then there is another class which is S3 Glacier Flexible Retrieval. If you request data from this Glacier, you would this particular class of Glacier, you would be needing time of minutes or hours to retrieve that data. So you would first initiate a request to get specified data. The job would run asynchronously behind the scene, and once the data is ready, you would be able to access it. That is your flexible retrieval. Minutes to hours of retrieval of data time would be there. So probably you won't be using it for services where you need instant retrieval. You can still use it, but if you are doing that instant retrieval very frequently, then it may not be very cost efficient. So be little conscious about when to use Glacier instant retrieval or flexible. The last one, which is the cheapest one available to store your data, is your Glacier Deep Archive. If you look at it, cold to time. So this is what my Glacier Deep Archive is. The lowest cost, few dollars for 10,000 GB of data, and you may have to retrieve data in 12 to 48 hour retrieval time. You would be waiting for that data to get retrieved. Right? So hopefully this thing is clear. And now you would also have access to this service summary card where I've listed basic stuff related to Amazon S3 Glacier, like what it is, when, where it is. It is a regional service. You would be choosing different storage tiers. Then you would be creating things for management console. And afterward, you would be using a job to query archive or get an inventory of vault. And then capacity charges will be there for you to pay. So that is all about Glacier. I hope you have learned something new and I'll talk to you into the next lecture. Thank you.